Welcome to Get Your FRQ On. This is from the 2000 exam. It's question 6, and it is not calculator active. In part A of this question, we are given a differential equation and asked to provide the slope field on a graph with 12 points. Like pretty much any slope field question, you're going to use the 12 points on the graph, take their coordinates, evaluate dy dx, and then sketch little line segments that have those appropriate slopes at those ordered pairs. So using the 12 points from the graph and the expression for dy dx, we get a slope field that looks something like this. Now, these don't have to be perfectly drawn, but they do have to be somewhat accurate, and they do have to be accurate relative to one another. And what I mean by that is your segment with slope 1 shouldn't appear to be steeper than a segment with slope 2. And a segment with slope 3/2 should appear to be somewhere in between the two. All right, so to fill in the slope field, we just take the ordered pairs here, -1, 0. If x is -1, -1 squared is 1. 0 minus 1 is -1, so I have 1 times -1. So notice this line segment has a slope approximately -1. And we just do that for the other 11 points. Part B asks us to describe all points for which the slopes are positive. Well, in order to do that, we have to take our expression dy dx and figure out, like, when is it going to be greater than 0? All right, so dy dx equals x squared times y minus 1 needs to be greater than 0. And then pay attention to how this will work. Notice, if x is 0, it doesn't matter what y is. The entire expression will evaluate to 0. And we don't want that. So one of the requirements that we have in order for the slopes to be positive is that x cannot be 0. All right, so let's assume that it's not 0. Will it make a difference if x is positive or negative? No, because we're just going to square away the sign anyway. So as long as x is not 0, the x squared factor will always be positive. Okay. Well then, in order for the entire product to be positive, I need to know when y minus 1 will be greater than 0. All right, solving that inequality is pretty easy. Y minus 1 is greater than 0 whenever y is greater than 1. All right, so dy dx equals x squared times y minus 1 will be greater than 0 anywhere on the plane where y is greater than 1 and x is not 0. In part C, we are asked to find a function f of x if f of x is a particular solution of the differential equation with the initial condition that f of 0 is equal to 3. Notice that the expression dy dx equals x squared times y minus 1 as a differential equation is a separable differential equation. Right? So we can solve this using separation of variables, which in many cases on free response questions, that is generally the expectation. If you can solve it using separation of variables, that is the expectation. All right, so let's separate the variables. All right, so dy dx equals x squared times y minus 1 would imply that dy over y minus 1 is equal to x squared dx. Okay, just moving some stuff around there. And as you learned in algebra, if you do something to one side, you have to do it to the other side, usually. So we integrate both sides. All right, so we have the integral of dy over y minus 1 equals the integral of x squared dx. Okay. We should be able to find those antiderivatives. Right? So the antiderivative of dy over y minus 1 should be the natural log of the absolute value of y minus 1. And the antiderivative of x squared is 1/3 x cubed plus c. Now, do not forget the c. Very frequently with free response questions, if you are expected to find an indefinite integral, you must have the plus c or you will fail to earn at least 1 point, oftentimes more than 1. So do not forget the plus c. A couple of reasons. One, it's good practice. Two, we're trying to find a particular solution to this differential equation, and the c is necessary in order to do that. So do not forget the plus c. You don't need it on both sides, right? If you have a c1 on the side with y and a c2 on the side with x, it's not technically wrong, but just consider, subtracting c1 from c2, which would be another constant, and so you can get away with just having one constant on one side. All right, so if we have the natural log of the absolute value of y minus 1 equals x cubed over 3 plus c, then that means the absolute value of y minus 1 is equal to e to the x cubed over 3 plus c, which is e to the c. Remember how exponent rules work. The sum of two powers there is just the product of two powers with the same base, so the plus c can be thought of as e to the c, a constant multiple of e to the x cubed over 3. So typically what might happen here is you might substitute e to the c as just some other parameter k. It's a constant, so it doesn't really matter. We might need to find out whether or not that constant is positive or negative, but not at the moment, so we just allow k to equal either the positive or negative version of e to the c. We'll figure it out later whether or not k has to be positive or negative, if we need to at all. So if we make that substitution, we get y minus 1 is equal to k times e to the x cubed over 3. Notice that by allowing k to be either the positive version of e to the c or the negative version, we no longer need the absolute value at this point. We will handle the absolute value when we determine the sign of k. All right, so picking up where we left off, using the initial condition, which is that f of 0 is equal to 3, 3 minus 1 has to equal k times e to the 0 cubed over 3, which means 2 is equal to k times e to the 0, which implies that k is equal to 2. So y minus 1 equals 2 times e to the x cubed over 3, which implies that the function y is 1 plus 2e to the x cubed over 3.